want to introduce everybody online to Dave Hamill. Dave and I go way back. We've been working on material handling logistics projects for 25 years.
Yeah, since we were young pups.
Yeah, since before, since we were younger, yes. Dave is with Ghafari Associates. They're based out of Detroit, and they do a lot of logistics, PFAP-oriented studies using the Proplanner suite, and in fact, probably one of the foremost groups doing Tugger analysis studies for companies. And so Dave came from Detroit here to present one of his latest small lot Tugger analysis projects using the Flow Planner software that feeds off of the PFAP database. So with that said, I'm going to go ahead and we are sharing the screen and turn it over to Dave Hamill.
Oh, that's okay.
Thanks, Dave.
Yeah, you're just going ahead. You saw a little preview of what's coming. This is a fairly small study that we've done, and this was my first time of really immersing myself in the new, what I call the new small lot module, because I've been working with Dave since 1990 or something like that, from the very beginning. So over 30 years. Factory Flow was the software we used then. That was for bulk and small lot flow modeling and material handling activities. And then it became Proplanner that we shed that. And we've been using, and I've been using the Flow Planner software module for 15 years directly right now, since 2007 when I left Ford. For 15 years before that, I was working with Dave because he used to come to Ford, and believe it or not, would sit there at our Ford engineering office, body assembly, material handling engineering, and he would sit there in our office for a week or two at a time, literally every day. You know, if we didn't ask him to come, he came. And he would sit there and listen to us using the people that were using the software, and he would take suggestions on improvements and things from the people that were coming, you know, during the day when we were working with it. And he would write code. He was trying to improve the functionality of the software. So that made a heck of an impression on me, and it's one of the main reasons I'm here today. I'm honored to come here and share a little bit of my experience and adventure using some of the software. The other thing I wanted to say before I get into it, now this thing won't be too long, I won't drag this thing out. But I wanted to say that responsiveness of this company was something that I've counted on my whole career, and I've been a director again since 2007. Now, in 2007, I had been a manager of Group Ford before that. I had worked with these that did all this stuff, so I couldn't actually use the software without getting in trouble. But in 2007, I left Ford. And now I could, and I want, trying to follow my heart, do what I like to do. And this kind of stuff I like to do, believe it or not. I'm just, I don't know what I'm still trying to figure it out, kind of let it go where it goes. But I can remember vividly, in 2007, I was working Power Automotive, doing some flow modeling with the bulk tool, and I have a habit of using this software. I get myself in trouble. I find a way to break it, and I get to sit that on or something stupid. It's got to connect the dots. You got to get these things where everything connects precisely, or if something doesn't run. Right? So it was Christmas Eve, and I was in a panic, and I called Dave, and it was actually it was in the evening, Christmas Eve. Dave answered the phone, and he actually did some checking and did some code changes for me, literally that night, and I was able to get the model going again. So I had it for January 1st after the holiday came back. So that's unusual support, in my opinion. So I applaud you guys for that. Keep it up. Let's see here. Which one do I hit to go? All right. Which one do I hit if I want the little? Yeah, the cursor to show or something. Do I hit? Oh, I'm sorry. Sorry, guys.
Other bounce button to go back.
There we go. Whoop. Oh, this is going way back. Okay, this thing has got a mind of its own, baby. All right, I'm going to forget that. Let's start with Ghafari service. The next 3 slides are just an overview of Ghafari. I got to go through this marketing demands. Okay, integrated enterprise elements. The kind of things that Ghafari does: full service architecture and engineering, operations, system engineering, business and operations consulting, IT and security systems, program management, and for professional staffing. Capabilities, pretty broad. Started out as an architecture company. They acquired some other companies since they were founded, and now they're doing a lot of manufacturing engineering work in addition to, and we're getting into laser scanning and operations and systems engineering. So we're branching out and we're trying to grow our wheelhouse. Markets primarily automotive, aviation, commercial, education, government, healthcare, industrial manufacturing primarily, and workplace. Here are current global locations of Ghafari. Always work in progress. It's grown quite a bit over the last few years. And hopefully we'll continue to. So with that, we're going to get into the meat of this. The problem we had a plant here, Detroit local plant next to an auto OEM. We needed an indirect labor plan for small lot container replenishment, the totes that go from a market area to the line, lots of fasteners, little boxes. 300 square foot plant, 300,000 square foot plant, providing mainly in sequence assembled chassis subsystems. And again, for a local assembly OEM. So these are assembling in sequence and shipping in sequence to a nearby plant. So it's a pretty high stress environment, needless to say. This is a new plant that is launching in about a month. Labor budget exists, but there's no detail. So they have a budget for doing this small lot replenishment, but there's no detail and nobody's comfortable with that. So that's why we're asked to do the study. The client, one thing that the client preferred to do is they have a tote decant step that has to happen between the dock and the CMA storage. That's to take the totes off the pallet when they come in and put them in the flow lanes that they have to be in for the operator to pick for small lot replenishment. That was typically going to be a fork driver task instead of a small lot driver task, but they were interested in knowing if they could end up having enough extra time to do the tote decant as a part of the cycle for their operator. So that was something we couldn't determine without using the software. So we were able to show you in a little bit. Also, the other thing too is kind of an, oh, by the way, work instructions for small lot operators is something that we have to do as well. And there's some output from this that is relevant for that documentation. The ideal solution, easy data setup and update. We've been hearing this from everybody. Quick to run. Enables iterative analysis because the small lot tool is an iterative type tool. You have to start with a baseline and then you have to continue iterative reruns until tweak, rerun, until you get something you consider to be optimal. Something that generates detailed output so we can get a lot of data to chart and understand, compare, contrast, you know, the data analysis afterwards is pretty important. And it's easy to validate the software calculations inside the program. So we want to know how the thing thinks. That's the ideal solution. Options considered: manual calculation, Excel modeling tool. We've got Excel workbooks. Not real happy with them. Not real confident in their output. Actually measuring what we're facing and how we need to allocate resources. So we're jumping right into this. Here is the result of some iterative analysis where we developed the small lot plan. What I'm showing you here on the left are the Euclidean flow routes, point to point from the activity points, in the CMA, which is in the bottom right corner, where they pick the parts. That's that small area down at the bottom. And on the right side is with a couple of arrows that are facing each other in the bottom right. The blue route and the red route both go through the same CMA, but each one goes to different U-lopes. The front, the blue route primarily delivers to U-lopes that are assembling front, like front subframe assembly, and the rears for the rear subframe assembly, etc. Right. So that's how it was broken up, and that was kind of an arbitrary separation to see how it worked, and it worked out pretty well, so we left it. But on the left is the Euclidean, on the right is the actual path, which those are the actual paths that the tuggers drive on the red and blue routes, which you can't see everything because you've got lines superimposed on top of each other. So we use various graphical capabilities of the software to help with that. This iterative modeling approach is necessary really to achieve efficient flows and balanced work. And I'll show you some examples of what we came across here. Here's one regarding route flow optimization, and this is like where you're traveling to between the red and the blue, because it was kind of a workload balancing exercise between red and blue. If you see up there on the top, there's some U-lope or line side stations they had to deliver to that are up close to a remote area that the blue line services. So you got the red line and the blue line, and both in a remote area. The opposite, let's assign it to the blue line, pick the red line off of that, and make it a better flow. That's what we ended up doing. So when we did that, we ended up with more efficient flow. It ended up affecting the time in a favorable way for the time required to perform the work. The good thing here, these flow illustrations are super. And in the same way with the bulk tool and the small lot tool is one of the key values of this is having the illustrations where the audience can really understand what the heck is going on with the plan. because a lot of times they can't. This gives them at least a leg up in there. So in any event, what these illustrations do, in my experience, is they highlight things that are opportunities for improving the flow. They jump off the page at you, and you wouldn't be able to see them necessarily without the tool. This is for aisle congestion, so it's the amount of traffic in the aisles. Another feature of the software, both in the bulk and the small lot. This one here, there were some earlier iterations of this study, because this thing has been iterated, geez, I don't know, dozens of times now, with tweaks in between each one. And the congestion in the area circled was higher before than it is now, but it's still a good comparison. This was an area of concern for plant traffic because most of the handling in this plant is done by forklifts. So it's handling big cradles, big carts, to and from the line, to and from the dock. And that area is a high congestion area for forklifts. So we wanted to keep the tuggers out of this area as much as possible. What we had before was a two-way aisle. Here, a two-way aisle here. That was one thing we decided to change and see what happened. And what we did was we changed that to a one-way aisle going east to west. And then we swapped the direction of aisles on that line on the far left. And we moved the congestion away from that area that we wanted to protect and free up. And we moved it into areas where it wasn't such a problem. This is relative congestion. You can see the Proplanner allows you to aggregate the threshold of the breakpoints based on something you arbitrarily select, or you use a class curve percentage, 10, 20, 20, 20, 10. It'll do that. So it gives you those options. So in any event, we were able to improve this. The iterative analysis helps manage congestion. So again, the software is doing things we can't do in any other means or any other platform. I've got a couple slides here just to show. This one is for the front routes, and it shows there were 21 routes. There were 3 shifts in this plant. 1-hour routes. They had 7.3 hours of work time, subtracting their break. So we opted for 7-hour routes per shift. And times 3, we get 21. And so our shift 1, 2, and 3 are shown there, left to right, top to bottom. And all of the flows are similar, but they're all unique, and this is something that is good fodder for work instructors, for operators who want to feel comfortable that they're being given a job that somebody has studied enough that it can be done. Okay. Without it, you can't do that. Now on the reds, their observation was similar. Most of the routes flow clockwise, but there are 2 exceptions. They flow kind of counterclockwise. It's just, the statistical analysis capabilities of the software. So it gives you the, some of the bookends here that you might need to plan for. So again, it's all pretty consistent. You can actually track, if you wanted to blow one up and just track, you can get output data and you can track each step. You can see I went to this workstation, I delivered this part, before I delivered duplicated this part, whatever. You could follow, you can mine down in the data and get all that. I didn't do it for this, but you can get all that. This is another aspect of it. It lets you measure the utilization of your tugger cart strings, the dollies you're using to put the totes on. It might be 1 or 2. In this case, we use 2. We assumed that we had a small cart, 2 small carts attached to the tugger. Each one can carry 45 totes. That was the client's assumption. So we studied it based on that we would have 90 totes capacity on a string of 2 carts. And for route 1, through all those studied routes, 21 routes, the average was 32 totes on the 2 carts, and the max was 39. So well below the 90. Route 2 was a little higher, 55, 69. Again, tug string capacity of 90 totes is adequate. That's what we gleaned from that. This here is a chart of utilization. You've got travel time in the bottom blue, unload time is orange, and you've got an efficiency uplift, which I can explain later, but it was a common uplift because of IT issues they had there. All the tasks for decanting in this particular scenario were assigned to route driver 1, and that was because route driver 1 had more available time than route driver 2 when you compare the 2 bar charts. The route driver 2 up at the top was close to 100% utilized already without the decant. Route 1 could handle it. So we're proposing that it goes to route 1. We're presenting this next Tuesday. It's probably going to change a little bit because I have air picture. So work was balanced by separating discretionary tasks. So again, something we couldn't have gleaned from, and through the iterations, we had times when we had different the bomb was changing throughout this period as well while we were studying it. And we had times when we were splitting the decant paths across two because both of them were more evenly balanced without the decant than they are in this scenario. So we were spreading it out, saying one do one, one portion, another do the other portion. So again, we were fine tuning this thing. This was like a summary of what that count required. Group number 9 is route 1. Group number 10 is route 2. We're assigning all the decants for route 1, which is taking it up to about 90% utilized. And that was where route 2 was before we did that. So we got both drivers utilized about 90%. So that's pretty good. So we think that we're protecting the plant with the plan, and we've got an appropriately conservative time study. We're not short on time. And so we feel it's a pretty responsible position to be in. Module experience. I have, like I said, 15 years personal experience with Flow Planner bulk modeling tool, which I started after I left Ford and bothered Dave on Christmas Eve. I had no experience with a small lot tool before this one, before this project. Okay, so this new version, I mean, it didn't realize, it kind of dawned on us before Christmas that you had some features in here that we didn't realize you had. So that was why we got together, was to get, start using this sucker. And so far we like it. Okay, we got some more learning to do. We don't feel like we're there yet. So the model setup was similar to the bulk study, but what was really good about it, it was simpler. The data mining, to get it set up, it took less formatting than it does in the bulk to get everything aligned the way it needed to be for the input cost. So that part we really liked. Some tilt time was required, and spent a lot of time referencing the user manual and the STDTR. You know what that is? No. That was your Tugger analysis.
Oh, the video?
Yeah, the video. Okay. Anyway, after numerous iterations, cries for help to Dave and Robin, the small lot model was born. And I'll say one thing about these bulk or small lot, whatever model you're doing. I mean, I'm a guy, and I'm probably about the closest I'm ever going to come to birth of a baby. Just have one of these things work. Okay, that's kind of how you feel, when you get done with this thing. So all of a sudden it works. Wow. Because of the soap time it took me to get to where I'm at right now, I'm confused at a higher level about more important things. Future studies will require less lead time than this one. What do we like? Simple data setup, minimal data inputs, and they generated a substantial amount of output. I mean, the ratio was, in my opinion, huge. Favorable huge. Future studies like minimal data inputs generate output, good AutoCAD visuals. Like I said before, the visuals are kind of priceless. It's kind of like if you don't have that, you're going to miss things. And that's been my experience. It's efficient at what if analysis. You tweak a couple little things, you rerun right away. So you can run, iterations fairly quickly. And the other thing, which I really haven't had a chance to experiment much with, other than just run it one time, is afraid to see. So I want to experiment more with that on what kind of variability that generates. Opportunities, output data reports need reformatting. The output data has to be taken in its form and converted into, like a flat file or something else. Some of it becomes flat, some of it doesn't. So that takes a little bit more work, but not enough to make us not want to use it. Okay. Next steps, we plan to use this Flow Planner bulk and small lot tools like we have been, but being even more aggressive on projects where work measurement and allocation is required. And like I was telling Dave, I'm getting thrown on one as we speak right now, which is going to be a good one, using both bulk and small lot in a plant that builds engines. So this will be interesting. So we need more practice with it to get comfortable. We're going to get that. What I've learned today is that I've probably been living on the wrong planet. You've got a lot of software here that wasn't even aware it existed. Nobody in here has presented anything on Flow Planner, which is all I've known. My life is Flow Planner, and it isn't even on here.
You are the Flow Planner guy.
Yeah, right. So I feel like I got a little catching up to do. That's why I call myself improve the day. I got all this stuff to look forward to, right? So I'm pretty excited. A particular interest, PFAP, assembly planner. There's other stuff. The MES stuff you got, some of the other tracking things you got, almost everything you put up there. It's pretty cool. So, our challenge is going to be figuring out how to integrate all these tools into something meaningful so we can do better jobs for our clients on projects. and maybe bring something to the party on these projects where we surprise and delight and exceed their expectations. We give them something they weren't expecting, and we maybe give them an opportunity to carry on using some of these tools and do more meaningful work. So that's what we're about. Anyway, that's it. Questions?